Good morning, good afternoon, a warm welcome to all our attendees today. Thank you so much for joining us today for this webinar on building a sentiment analytics solution powered by machine learning. I'm Lisa Glenn, your host and presenter for today's session. Joining me today as the expert speaker is Sridhar Seshadri, the social analytics expert here at the Impetus Labs. Sridhar is among the significant contributors to our social media analytics projects and has been able to establish expertise in this domain. Now, in this 40-minute session today, we're going to discuss the need of building a sentiment analytics solution based on machine learning to gather better business insights. So let's go ahead and have a look at what today's session has in store for us. The focal point of this webinar today is how you can build a sentiment analytics solution powered by machine learning. And let's just start with addressing why sentiment analysis is vital in today's world. We're also going to be talking about the current solution landscape and why we recommend using machine learning to build your sentiment analytics solution. Later on in the webinar, we're going to share with you our recommended solution and some actual real-life case studies where we use sentiment analysis using machine learning for measuring campaign effectiveness and analyzing the brand perception and performance. So let me begin the session today with a basic question. What exactly is sentiment analysis? Now, if we just go by the textbook definition, we say that, quote, sentiment analysis or opinion mining refers to a broad area of natural language processing, computational linguistics, and text mining. But generally speaking, sentiment analysis determines the attitude of a speaker or writer with respect to a particular subject. Now, this attitude may be based on their judgment, maybe an evaluation, or the affective state, which is to say the emotional state of the author while writing. And it can also be the intended emotional communication, that is, the emotional impact that the author would really want to have on the reader. Now, I would have to say that sentiment analysis is a discipline that really helps organizations measure and evaluate and basically explain the performance of their social media initiatives based on the opinion or sentiments that people express on the various social portals out there, such as Twitter and Facebook and so on. Now, on your screen now, you can actually see the 4 stages that are involved in measuring sentiments. Now, the first and foremost event that acts like a trigger to the process is the launch of a campaign on various communication channels. Now, once this happens, in the second stage, the target audience almost immediately reacts online. And their reactions provide just a collection of opinions and sentiments about the campaign and the product. So once we have those reactions, the next step is analyzing them, or the sentiments, where the findings are then presented to the top management, strategists, and other stakeholders, such as the sales and marketing team. Now, all this visual and interactive information facilitates better insights. So now here is where a sentiment analytics solution is used for gauging the performance of a campaign or product or maybe a brand, and to check how well received they are in the marketplace. So based on all these insights and analysis comes the important innovation stage, where the businesses respond to what their target audience is saying about their offerings and accordingly manage their reputation. Now, it also really helps them identify how and what their existing customers are talking about, and then appropriately design a CRM system. It also enables them to track any changes in perception over time. And so we really believe that in order to quantify the reactions and be able to derive actionable insights, sentiment analytics is the key. So let's now just take a closer look at options currently available that facilitate sentiment analytics. So sentiment analysis is conventionally handled by a couple of popular techniques. The first one being natural language processing, and secondly, by artificial intelligence. So in the first option, the algorithm is trained to understand the natural language and then draw inferences from it. Now, this option usually is not very successful because it's really deterred by factors such as internationalization, as well as that unique lingo that's used for tweets and Facebook status updates, which, as we know, is just a lot different from the natural language. Now, the second option uses information by NLP and mathematical calculations in order to determine negative, positive, or neutral sentiments. The machine learning solution is a part of artificial intelligence, and we're actually going to discuss that a little bit more in detail in the upcoming slides. So basically, sentiment analysis just opens up a host of new opportunities and new perspectives. But before we can leverage them, there are a few challenges that you have to overcome. And I'd like to discuss just a few of those challenges now. So the first one that I want to share here is ensuring a higher degree of accuracy while you're gauging sentiments. The key is writing an efficient algorithm that can help you achieve a lower false positive rate. Now, this implies that, say, a tweet, which was maybe supposed to be classified as a positive, will be classified as a positive, not as a neutral and not as a negative. Now, in a machine learning-based system, we measure the accuracy of a system based on how low the false positive rate is, which should ideally be lower than 4 to 5%, depending on the training data set and the information that we give to the algorithm to learn. The next problem that you may encounter is the inconsistency across social networks and just the neutral nature of social media mentions. And let me give you a quick example. Tweets are usually about 60% neutral. Most of them just don't have opinions or really any explicit sentiments. It's also really difficult to determine the total overlook actual verbatim, which is caused by people retweeting or updating the same status again and again, thereby diluting the sentiment's overall strength. Now, another problem area is the inability to allow clients to leverage contextual knowledge in order to apply the accurate sentiment scores. For example, most of the current systems just can't detect sarcasm, and therefore, in order to get a higher accuracy, we actually need to use sentiment override. Now, before we move on and talk a little bit more about machine learning, I just want to take a little poll break here and would like to ask our audience, what, according to you, is a better source of social media input for sentiment analysis? Now, your options are Twitter, Facebook, a combination of these, or possibly other social media websites. Now, you can answer that poll on the right of your screen, and you have 30 seconds to do so now. Jadhar, do you have the results and would like to comment on them?
Yeah, Lisa, I really see a point in the audience's response to this question. I mean, combination really would make sense. Usually, the perception is Twitter is really a place where it seems to be a low-hanging fruit kind of thing, where we find information pretty easily. You don't have to put an effort to mine the information on Twitter, but it's all about the combination. You just need to identify where your audience lies and from where you want to mine the information, and that really works well.
Thanks, Sridhar. Let's go ahead now and just discuss machine learning now. So we believe that the challenges that we discussed in the previous slides can actually be addressed effectively by machine learning. So let me just tell you a little bit about how machine learning helps. Now, it just goes without saying that we use computers for almost everything nowadays, and computers really need better intelligence to cater to our needs better. Learning and knowledge is central to intelligence, and machine learning is able to take care of this requirement. It's really a structure capable of acquiring and integrating knowledge automatically. Now, the ability of the machines to learn from experience, training, analytical observation, and other means gives us an intelligent system that can continuously self-improve and therefore really exhibit efficiency and effectiveness. A machine learning system ideally possesses a certain level of knowledge and associates itself with a corresponding knowledge management organization so that it can effectively interpret and analyze and test the knowledge that is acquired. So now that we've discussed just some of the challenges for analyzing sentiments and established machine learning as our favorite approach, I want to now discuss some critical questions that an ideal sentiment analytics tool needs to address. And they deal with subjectivity and sentiment, analyzing the polarity of reactions, and gauging sentiment intensity. And we're going to go through all of them in detail in these next slides. So let's go ahead and start with sentiment versus subjectivity. Now, we talked a little bit earlier about tweets being classified as positive, negative, and neutral. So the question that we're going to address now is, how does a machine know about subjectivity and sentiment? We simply define subjectivity as the linguistic expression of opinions, of sentiments, emotions, evaluations, beliefs, and, say, speculations. The basic components of sentiment analysis involve a sentiment holder, which is a person or perhaps an organization that holds a specific opinion on a particular focus area. Now, the second component is the object on which a sentiment is expressed. And lastly, the actual sentiment, which is the view or attitude or maybe appraisal on an object from a sentiment holder. Now, in order to define what is subjective and how to use it in sentiment analysis, we use a statistical and probabilistic approach. Now, the second big question that any sentiment analytical tool needs to address is, how does a machine analyze the polarity of reactions in terms of negative and positive? Machine learning plays a really big role in deciding that polarity. Whether or not a sentence is positive, negative, or neutral is judged by an algorithm which refers to its initial knowledge bank to decide the particular polarity of any new sentence or new word. So basically, a knowledge bank is a database of some pre-trained words with information on the patterns of words and sentences that are defined as negative, neutral, and positive. So now, let's go ahead and address the third critical question, which is, how does a machine know about sentiment intensity? Whether a word or maybe a sentence, is strongly positive or strongly negative is decided by a couple of metrics. We first use a technique of benchmarking neutral. Say 40 to 50% of positive is neutral, and any intensity below that will be negative, and above it will be positive. Secondly, by referring your knowledge to your knowledge bank, which is being continuously trained and updated by a machine learning algorithm, the prediction then becomes more accurate about the intensity. Now, it really depends on the occurrence of a word or sequence of a word in a particular polarity that decides the intensity of that overall sentiment. Also, the accuracy of the system, depending on your range and the complexity of the language. So basically, the wider you throw your net and the more difficult your language gets, the less accurate your system is likely to be. Furthermore, it's just a lot easier to classify the sentiments on the basis of a positive and negative group, as opposed to maybe the scenario where you are further distributing them on the basis of exactness, say excellent or incredible or good or so on. Enhanced granularity here requires enhanced accuracy, and this in turn demands a deeper understanding of the human language. So having covered how machine learning can help address some of those key problem areas, let me share with you now a little bit on how this system actually works. To really understand this at a high level, we first pull the input text, say in the form of Twitter tweets, using search APIs. Now, alternatively, you could also use the Facebook graph search result or really any other REST API or XML output. You can now use a machine learning algorithm based on Bayes probability, as well as text classification and pattern generation that uses an n-gram technique to process all this information. So this processed information then generates results based on your initial knowledge bank, which again is a trained set of n-gram pattern text classified as either positive, negative, or neutral. The new information coming in is then processed and again labeled as positive, negative, or neutral. Now, to ensure that there aren't any false positives, there's actually a manual dashboard where you can review and correct the polarity. So once a false positive is found and corrected, the machine learning classifier reruns and then actually learns from the new training data set and corrects its calculations for intensity and polarity prediction. I'd like to just take a moment now and actually ask our audience another poll question. We would like to know what you actually would prefer to power your database stack in a sentiment analytics solution. And you have two choices. They're MySQL and NoSQL. And again, you have 30 seconds to respond on the right of your screen.
Yeah, I see this result has to be NoSQL, and I mean definitely the poll really makes a lot of sense to me, as analytics is always associated with big data to solve the real challenges, and that lies in drawing insights from huge unstructured and structured data. But I would want audiences to think about this. Like, let's think of a simple use case. Let's this be a simple supporting ticket solution, where the data is pretty much structured and the information is not generated in huge quantity. And to get quantifiable insights on the customer satisfaction, we can still consider keeping the backend stack on MySQL in any of these kind of use cases.
Okay, great, thanks. So building a sentiment analytics tool which leverages machine learning, facilitates low-time complexities without sacrificing performance. So the first step in building this tool is to come up with some simple and effective methods. We propose actually employing the N-gram approach for text classification here, which is frequently used to model a phenomenon in natural languages. Now, it is possible to develop two simple variations of this approach which yield high performance ratios for filtering sentiments. The second step in building the tool is exploiting the human behavior to know their perception of sentiments. So, for example, whenever a new text is received, the system will first read those initial parts of the text and then decide whether the incoming text is headed toward negative or positive. Now, in case the sentiment is negative, it's actually not required to read the entire text to conclude that the sentiment is negative. Just a quick glance would actually suffice. Now, we simulate this human behavior by means of heuristics, which is referred to as the first N-words heuristics. Based on this, just considering the first N-words of an incoming text and disregarding the rest, you can actually yield the correct class. You actually can now see how we use the N-gram text categorization from the diagram on your screen right now. Now, to make things even more complex, this process of tokenizing text into a word is different for every language. And of course, there's numerous forms and tenses that are used in any language. For example, in English you have the word walk, walking, and walked. In Spanish it's caminar, camino, caminado. Now, all these words represent the same meaning, but since they have other written forms, they do differ in terms of polar intensity. Now, there is a solution though. We can address this issue by implementing an N-gram generated pattern, which is a subsequence of N items from a given sequence, instead of words. N-gram primarily considers the sequence of alphabets or characters that makes a word rather than their language, and therefore it's likely to succeed where the NLP-based solutions may fail. Using N-gram as a substitute of phrases, it definitely has numerous rewards. It makes the process language independent because it's just not essential to use a stemming algorithm. Now, it also analyzes the text words in terms of N-grams in a manner that's also idiom independent. So, by detecting patterns in training samples, the system can then be trained to progressively distinguish positive and negative sentiments, where then the training data can be stored in a big data stack. Now, it also has an exceptional way to parse and extract the functions. And again, since it's not operating with words, it just doesn't care about the language. Let's now take a look at how we build a knowledge base. A knowledge base includes a database table with the information of N-gram patterns, again identified as positive, negative, or neutral polarity, generated from the initial training data set. The two core advantages here of N-gram model is its relative simplicity and the ability to scale up by simply increasing the N. This N-gram model can then be used to store more context with a well-understood space-time trade-off, enabling small experiments to scale up very efficiently. Therefore, the training data in a big data stack is feedback loop enabled, which means that the new classified n-gram patterns are labeled as positive, negative, or neutral. And this data, in turn, starts influencing the polarity intensity prediction model for the existing pattern, making this a much more accurate knowledge base now. So, for example, a pattern generated, say, for the word rubbish will be treated as negative, and the algorithm will be able to actually identify words like rubbish, rubbishing, as also negative itself. I'd now like to ask Sridhar to share with you all how you can leverage machine learning for analyzing sentiments. Sridhar?
Yes, sure, Neeta. Thanks. I would just like to explain this pretty quickly and like to share what's there on the slide. A tweet or a Facebook status text is first processed by an n-gram filter for generating pattern. If the pattern already exists, the pattern's polarity intensity is increased or decreased based on the text classification. Else, a new pattern is generated and is labeled by its polarity on the existing training data set. This pattern is processed through a Bayesian filter that is based on the principle that most events are dependent and the probability of an event occurring in the future can be inferred from the previous occurrences of that particular event. A probability value is then assigned to each word or a token. Now, this value based on some calculations that take into account how often that word occurs in one category or another. The most common application of the filter is to identify words that appear in the negative sentiment category or maybe in the positive sentiment category. This solution breaks down the content to improve the filter by supplementing it not only with a database of words to categorize, but also set of n-gram derived from the text. The algorithm also helps with the extraction and offers a few more layers of depth for Bayesian filtering. Now, based on the complete combination of patterns as well as the n-gram text, the Bayesian filter classification, the tweet is labeled as positive or negative. And as the information is again treated as a new training data set, it is reused to make the knowledge bank more intelligent by the algorithm. And say suppose if we cut down the feedback loop of the training data set and keep the knowledge bank intact for a specific use case, we can run it through n-gram filter and base classify it concurrently to get the results. In this complete process of new pattern generation, if there is any false positive, this can be manually corrected in the FB dashboard.
Great, thanks, Sridhar. We here at Impetus have actually successfully adopted this approach and have built a sentiment analytics solution which is powered by machine learning and is also able to leverage big data technologies. Now, our solution intuitively retrieves the input text for analysis using artificial intuition, which is actually a sophisticated function of an artifice that can interpret data in depth and locate hidden factors. Essentially, we've built a process of data interpretation synthesis in our system. Our solution actually integrates a computed knowledge base specifically on objectives, incorporating a paradigm called religious intuitive hermeneutic functions to a degree that really advances upon the performance of generic lexical data mining and interpretation. Now, this solution is actually smart enough to change its source of information between Twitter, Facebook, XML files, and text files, and filter out all the noise from the content which actually holds the sentiment. It also offers a great option to use the custom REST APIs for cross-functional teams to to build on top of the solution. It's really a very intuitive solution capable of processing near real-time data using the big data stack. Now, the solution works on LAMP, HBase, Hadoop, PHP Thrift, and has been tested for different scenarios. Our primary purpose for using big data is for analytics, and we're able to perform concurrent processing to enable fast results with much higher accuracy. Now here, the latency is more important than batching. So our recommendation is to use a combination of HBase and Hadoop along with in-memory architecture to leverage the huge unstructured data and provide near real-time insights. And while developing this solution, we balanced incrementing counters in real time with math-reduced jobs over the same data set to ensure data accuracy. Now, the tweet logs are injected into HBase at an increasing rate, and we're able to report metrics such as tweet throughput, unique user growth over time, and return tweet user activity in near real time. So our solution enables customers to handpick statistics on demand to gain that important market insight and be able to react quickly to trends. Now, this is all possible by processing the HBase data on HDFS by Hadoop to convert it from batch to near real time. This approach brings it 80% closer to near real-time analytics, and the remaining 20% would take some extra effort where you can introduce in-memory solutions such as Membase, Gigaspaces, or Memcached. In fact, in our solution here, we actually used Memcached. Now, there are some major advantages that our solution offers versus its contemporaries, and we're going to talk about those right now. So the first big advantage is that apart from a higher degree of accuracy, it really also helps identify influencers. So say after a campaign or product launch, an enterprise wants to know who's talking about their offerings, where, and say how. If the sentiment is largely negative, the enterprise needs to be able to quickly neutralize the mentions that may actually hurt their brand the most. So with our solution, they actually have the ability to drill down into negative mentions, identify the content coming from the most influential people in the industry, understand how far each tweet traveled, and how many people were impacted by the content. This inclusion of influencer analytics alongside sentiment measurement is becoming really a standard of the social media monitoring industry. Now, it also enables reputation management, thereby taking the influencer concept just a step further. Now, as far as sentiment algorithms are concerned, part of a successful prioritization process is to identify the intensity of each mention. Now, for example, if someone said, "I really hate product X and will never buy it," well, that's quite different from, say, "Product X is running a little slow today." So this ability to cross-reference intensity, influence trajectory, velocity, and sentiment of each social media mention drives us toward a very reliable priority system. So now I just want to take you through a couple of case studies where we actually used machine learning-enabled sentiment analytics solutions to measure sentiments. So in the first case study we're going to talk about, we searched for keyword Nokia Lumina on Twitter after their new campaign that came out. We actually analyzed 9,650 tweets with an accuracy of 99%. So tweets which had no sentiment and were just basic marketing tweets were pretty high in this scenario. So we went ahead and filtered out all the neutral tweets, which were around 42%. But 54% of the tweets with the keyword Nokia Lumina were positive, and we discovered that most of these were actually from Asia and Europe. Our solution showed us the useful tweets, and we really got some useful insights from their analysis. And you can actually see the classification from the image on your screen. So due to our analysis, we can safely declare that the campaign was successful for Nokia. Now, what was noticeable, actually, was that Lumina and PureView both were trending into positive sentiment. The Nokia CRM was actually getting good responses from its existing customer base, which we deduced based on the search of @Nokia official channel. The reputation was high for all hashtags searched, including hashtag Nokia, hashtag Lumina, and hashtag PureView. We additionally measured the brand management via a custom keyword search for Nokia without any hashtags or mentions. So let's now check out one more case study. So in this case, after a recent launch of iPad 3, we tried to gauge people's response to Apple's new offering. In this case, we decided to use Facebook as the preferred platform and use the search keyword as iPad 3. We then analyzed 3,200 Facebook statuses with an accuracy of 97%. And again, you can see those search results on your screen. And as you can see, there were around 53% neutral updates, 31% positive ones, and actually 13% negative. Overall, we have to say that Apple's performance of their online campaign was indeed effective, with the positive sentiments on brand perspective, CRM, and reputation that were actually pretty high. Now, before we wrap up today, I would like to now ask Sridhar to give you just a brief overview of how this Impetus solution actually works. Sridhar?
Yeah, thanks, Lisa. So what you see on your screen now would be the UI for our solution. So we have used the solution for running these couple of case studies, and here you see three inputs. One is for your brand name, second one is for product name, and third one is for making custom searches for analyzing how you are doing in market with reference to your competitors. Here we are looking for Nokia as a brand and Lumia as product for getting a general understanding of some features. Like we put those information fields info, and then we'll just click on let's analyze. You can now see on left hand side a real-time feed of tweets with its sentiment polarity and intensity of polarity in percentage. On right hand side column you see aggregated sentiment on a pie chart, which would show the overall result. Below that is an impact graph which helps you identify the impact of a tweet, like what kind of impact that is creating and how the trend could be. Next to it is an influencer graph about people tweeting and how they are connected to the keywords. What you're seeing right now is the impact graph, which shows you where is the sentiment trending to. The blue here represents neutral, green positive, red negative, the bigger the bubble is, the greater is the impact, and smaller the bubble is, smaller is the impact. So these tweets, they do have impact, and we calculate this on basis of the influencers who are tweeting it and how they are retweeting it, and or maybe influencer is tweeting it and maybe another influencer is retweeting it. So this is the impact display of like what kind of impact the tweet is creating. So the view that you're seeing right now is called influencer graph, which is generated based on how the same tweet is shared among many people and who is the real influencer. To identify who the influencer is, we would use this graph. So you would be seeing a demographics map here of Google. We have integrated Google's map APIs here. So when you click on the map, red pins, and this would actually show you the places where people are feeling negative about your product or brand. And if you click on the green pins, you would see where people are really feeling positive about your product or your brand, or maybe the campaign. So here is on your screen, you would see like to get some specific details on what is being said, from where, and how much of that is positive and negative. All you need to do is just look into the pie chart graphs. You can simply click on the demographics to get detailed information of like which country, which city, what people are talking about your product or maybe your campaign. Just about that, you can see a forecast graph which will actually tell you the trend, and it would even forecast like what may be the trend in near future.
Thanks, Siddharth. That was fascinating to see all those screens. And now, again, before we wrap up, I'd like to just take you quickly through some of the critical points that we discussed in today's session. So first, we talked about a sentiment analytics solution and really how it's used to gauge the performance of a campaign or product or maybe a brand, and to check how well they're received out in the marketplace. Sentiment analysis is really conventionally handled by a couple of popular techniques, which are natural language processing and artificial intelligence. Now, some of the challenges that we discussed were just the neutral nature of social media mentions, target overlook, actual verbatim, and sentiment override, which can best be handled by a machine learning model based on Ngram and Bayes filter classification. Also, we discussed about how a machine learning system has a certain level of knowledge and is associated with a corresponding knowledge management organization, which actually enables it to interpret, analyze, and test the knowledge acquired. Now, apart from a higher degree of accuracy, it also helps identify influencers. Now, including influencer analytics alongside sentiment measurement is really becoming a standard of the social media monitoring industry, and this solution has the ability to cross-reference intensity, influence trajectory, velocity, and sentiment of each social media mention, and just drives us toward a reliable priority system. So it looks like we've actually started to receive some questions from the audience, and I'd just like to remind you again that you can actually use the chat panel on your right to ask your questions. But before I take up some of those audience queries, I'd just like to take a moment to introduce Impetus Technologies. Impetus is a leading technology and R&D services provider with a strong focus and really established thought leadership in the area of data sciences and big data analytics. Our expertise also spans the domains of cloud computing, social media, test, and performance engineering, among others. So it looks like we're starting to get those questions from you, and it seems that someone would like to know the first question. What are the other models available other than Bayesian classification. Sridhar, what do you think about that?
Yeah, Lisa, actually, I'm just thinking about it quickly. So, compatible G priors and like variable selection, or maybe like model choices, etc. Basically, any good probabilistic approach that gets you lower false positive and higher accuracy for your use case would be a better choice. But generally, we found Bayesian filter showed greater results for most of these use cases.
Okay, great. Now, it looks like someone else would like to know, is there any other approach for handling the text classification apart from Ngram? What do you think?
Yeah, Lisa, we can actually go by MDI approach, which is minimum discrimination information. So the MDI algorithm traverses the lattice of all possible partitions for this general automation, attempting to merge states that satisfy a trade-off that can be specified by the users. So MDI could be another approach that we can actually consider other than Ngram. So really, Lisa, to pause you there, I'm getting some questions over the mail. I would really like to take some of these questions sent by the audiences. So I'll quickly answer a few of the questions. So somebody asked us, is unigram or bigram approach, like which one is to be opted for? And so I would simply say we would go with the use case specific thing if you're making a custom solution. So we have opted for unigram because we get a higher accuracy with unigram, and we would be having a lot of unigram patterns generated, and to support that we even have like big data stack. So even if you have a lot of data, structured or unstructured, we can just hold that data using unigram. I'll quickly move to the next question. Somebody asked us, so sentiment is the part here. What happens if the same word means different in different contexts? So we have used the approach of Ngram, and Ngram really helps us here in this situation. So if I need to really answer this pretty simply, so say there is a word which means say good in French, and maybe if there is the same word maybe in Hindi which means like bad, the Ngram would really predict it. So Ngram pattern is something where it can easily predict what would be the next word, and the combination of words that is actually taken in consideration while making a sentence really helps you to identify whether it's going towards positive or negative. So it's actually the overall sentiment override there rather than just considering about a word. I would like to even take one more question here. I got one more question from audience, and the question is, would this model take into account the context of the sentence? Something as simple as not rubbish to more complex contexts where wouldn't a semantic analysis be required? I mean, this is really a good question because we really thought about it. Semantic analysis is pretty much required, but to not make it too complicated, we actually opted for Ngram. Ngram would really take care of this because Ngram would even predict so whether not after the word not, should we really expect another negative word or positive word, and this would be really judged or predicted by Ngram classifier itself. So you really don't have to get into semantics analysis, you can just leave it to Ngram classifier and it will take care of it. I guess I'm getting like few more questions. I'll quickly take like a couple of them. Somebody has asked a good question on how many tweets per second per core. You really don't have to worry about per second per core because it all depends on your use case. So if you are looking for keywords or information where people are pretty much real-time tweeting about it, and if you are not storing all of those tweets and you are just like getting the final trend stored somewhere, you just really don't have to worry about number of tweets per second, because we have tested it for scenarios where we took like 100,000 tweets per second per core and it really worked well. I would actually take this interesting question on big data analytics. Somebody has asked us, big data analytics usually use distributed processing, which operates in batch mode, such as Hadoop. What kind of technology stack do you use to model and process on real time? So Lisa really did mention a little bit on this, like how we are really taking care of like making it near real time. So we are using MapReduce, which is pretty much on HDFS and Hadoop, and the data is on the HDFS data stack here. And to manage it, like MapReduce and Hadoop would do the 80% part of it, and the rest 20% part of that would be taken care by Memcache or any of the solutions where you can create a temporary memory. So maybe that answers the question. Somebody has asked us a question on how many n-grams need to be stored for an actual production deployment, and there is a following question on that: what is the maximum n in n-gram here? So to quickly answer that, how many n-gram needs to be stored for an actual production deployment, it is really again a case specific kind of thing, or like a use case specific thing, where you need to decide like how much of information is really needed to get the real insights or maybe actionable insights from the data. So we tried storing most of them for a specific use case study of Nokia, and it's all up to you. If you just want to, if you're getting really higher accuracy and lower false positive rates with lower like information being stored, just go with that knowledge base. Otherwise, if you feel you need to add more data, just go with like a higher n-gram there. And if you're just like thinking about what could be the maximum n in n-gram, I would seriously suggest not to push n-gram to a bigger number. Just try to keep it as small as possible. The only problem would be the performance in those situations, and you can even optimize the performance by using Memcache or any of those memory solutions. Because the smaller the n would be, if you're using a unigram or maybe a bigram approach, you'll get a better result, because the n-gram would predict pretty much more well with a smaller number of n. I'll take a last question and we'll wind up with that. So the idea that human sentiments can be classified by smile, neutral, or frown might be far too simple to provide actionable intelligence. Please expand on why you have chosen to go into this direction. Somebody asked this beautiful question, and I think I can simply answer it. We kept the n-gram as one here. It's unigram approach, and it becomes pretty easy for us to identify a smiley when we make it a unigram, because your colon and your a bracket would actually make it pretty much simple. Like these would be two simple patterns that are like tagged or labeled as positive or negative in our knowledge base, and this would really make things pretty easy. So you don't even have to get into part of like just dividing or like segmenting something as like smiley or like frown. The n-gram would really do it like if you add that information once to the knowledge base. So that is it.
Okay, thanks, Radha. I'm glad we were able to add those questions in. They were great questions. Again, thank you so much for your time today. And again, we hope that this discussion was a learning experience for everyone and really add value to your social media and analytics initiatives. If you have any other further questions, please feel free to email us at inquiry@impetus.com, or you can visit our website at www.impetus.com. Before we go, I'd like to quickly share with you that we're actually going to be sponsoring and exhibiting in the Cloud Computing Expo in New York. Now, as a special offer to our webinar attendees, we are giving out a free gold pass worth $2,000 for the expo. You can write to us at inquiry@impetus.com to get this offer. Once again, thank you so much for joining us in today's session. Goodbye.